Hello dear students, welcome to Karna Maths Academy. Today in this video, we are going to learn how to convert a complex number from algebraic form to trigonometric form. Now we are going to change x plus iy, that means algebraic form, into trigonometric form. So let's make a diagram, a very simple diagram. If we draw two lines perpendicular to each other, the horizontal line is called x-axis, or we can say real axis. In the case of complex number, the x-axis is known as real axis. This is the real axis, or we can say x-axis. And the vertical line is called y-axis, and it is known as imaginary axis, or we can say y-axis. So dear students, now let's suppose the complex number x comma y, or x plus iy, as z equals to x comma y, which equals x plus iy. Dear students, now from the point z, as we know that every point in the Cartesian plane, or we can say in xy plane, represents a complex number. So when we draw the perpendicular line on the x-axis, then the vertical line represents the imaginary part, or we can say the y component of complex number z equals x comma y, and OM, the horizontal line OM, represent x component, or we can say the real part of the complex number. If we join O to Z, then the distance of x comma y from the origin, which is called the modulus of complex number, and we represent it by the letter r. So OZ is the modulus, or we can say the distance of x comma y from the origin. Dear students, let us suppose the angle made by OZ with the positive direction of x-axis in the anti-clockwise direction. So dear students, now let's apply the rule of trigonometry. So we are going to find x component and y component, that means the real part and the imaginary part of the complex number z x comma y, or we can say x plus iy, into trigonometric form. So by applying the rule of trigonometry, we get cos theta. Cos theta equals to b by h, OM by OZ. So OM equals x, the real part of the given complex number. So OM means x, and OZ, which is the modulus of complex number, we have supposed OZ equals r, which is the modulus of complex number. So after cross multiplication, we get the value of x. After cross multiplication, we get the value of x equals to r cos theta, r times cos theta. So this is the x component, or we can say the real part of the complex number x plus iy. Now let's find out the y component, or the imaginary part of the given complex number in the trigonometric form. So we know that sin theta, the trigonometric ratio sin theta, is equal to p by h, perpendicular over hypotenuse. So sin theta equals, so in this figure, perpendicular means y, that means the imaginary part of, and hypotenuse, that means OZ, which is equal to r. So after cross multiplication, we get y equals to r times sin theta. So dear students, the y component, or we can say the imaginary part of the given complex number z equals x plus iy, we have got y equals to r times sine theta. So this is the y component, or we can say the imaginary part of the given complex number. X equals to r cos theta is the real part, and y equals r sin theta is the imaginary part of. So dear students, we know that the given complex number is in the algebraic form, which is z equals to x plus iy. Now we can write it as x means r cos theta, x component, or we can say the real part, equals r cos theta, and I keeping as it is iota, which is the image unit, and y is r times sin theta. So putting the value of x r cos theta and putting the value of y r sin theta in the given complex number, we have got z equals to r cos theta plus I times r sin theta. So if we take r common from both of the terms, we get r times cos theta plus I sin theta. So dear students, the algebraic form of complex number, which is z equals x plus iy, or we can say the x plus iy form of complex number, we have changed into trigonometric form, which is also known as polar form, where x equals r cos theta, the real part of complex number, and y equals r sin theta. So after substituting both the x and y components in the algebraic form, that means in x plus iy, we get r cos theta plus I times r sin theta, and after taking r common, we have got r times cos theta plus I sin theta. So this is known as the trigonometric form of complex number. Dear students, after converting complex number in the form of trigonometric form, r is equal to root x square plus y square. So if we use Pythagoras theorem, h square equals p square plus b square, or we can say h equals p square plus b square. H means r, and p means y, and b means x. So r means we get root x square plus y square, which is known as the modulus of complex number. This is the modulus of complex number. And tan theta, so tan theta means p by b, tan theta means y by x, that means theta is equal to tan inverse y by x, which is known as the amplitude. Dear students, theta is known as the amplitude or argument of a complex number when a complex number is expressed in the trigonometric form. So dear students, if we know r and theta, which are known as the polar coordinates, we can convert the algebraic form of a complex number, that means x plus iy form, into trigonometric form by finding the value of r and theta. R means root x square plus y square, and theta means tan inverse y by x. So let's take one example now. We are going to change a complex number from x plus iy form to the trigonometric form. So let's take one example. Suppose a complex number 2 plus root 3 times I. The complex number 2 plus root 3i, we can write as 2 plus root 3 times I, or we can write 2 plus I times root 3. Both are correct, where I is the image unit known as iota, which equals square root of -1. So we are going to change the complex number 2 plus root 3i from x plus iy form to trigonometric form, that means polar form. So let's suppose 2 plus 2 times root 3i, which is in algebraic form. So we can suppose 2 plus 2 root 3i as x plus iy. Therefore x. So after comparing 2 plus root 3i with x plus iy, we get x equals to 2, which is the real part, and y equals to 2 root 3. Y equals to 2 root 3, which is the image part, or we can say y component. So dear students, to convert algebraic form from algebraic form into trigonometric form, we have to find r and theta, which are called the polar coordinates of a complex number. So we know that r equals to root x square plus y square. X means 2, so 2 plus, now y square, x means 2, so 2 square, and y means we have got 2 root 3 square. So this means 2 square means 4, 2 square means 4, and root 3 square means 3, so 4 is 12, square root of 16 we get 4. So this is the value of r. That means the modulus of given complex number. Now next we are going to find the amplitude of complex numbers. So we need two terms, we need two coordinates, one r and other theta. So dear students, we know that the amplitude, that means theta equals tan inverse y by x. So let's plug in the value of y, that means imaginary part, which equals 2 root 3 over x. X equals 2. As x equals 2. So after cancelling 2 from the upper part and lower part, we get tan inverse root 3. Dear students, we know that root 3 is the value of tan 60 degree. Tan 60 degree. Therefore, theta, the value of theta equals 60 degree, which is the amplitude, or we can say the argument of complex number. So dear students, here we have got the value of r, which equals 4 units, and theta, which equals 60 degree. So these two are the polar coordinates. So dear students, to convert x plus iy form into trigonometric form, we need to find the value of r and theta. So after getting the value of r and theta, now after getting the value of r and theta, we can write 2 plus 2 root 3, which is in the algebraic form, that means x plus iy. So we know already x means r cos theta, plus I. Y means r sin theta, which already we have found. Already we have proved I sin theta. So r times cos theta plus I sin theta is known as the trigonometric form. So let's put the value of r. 4 cos theta means 60 degree plus I sin theta means 60 degree. So dear students, the complex number 2 plus 2 root 3i is equal to 4 times cos 60 plus I sin 60 degree. So in this way we have changed the given complex number 2 plus 2 root 3i into trigonometric form. So dear students, I hope you have understood how to convert algebraic form into trigonometric form geometrically, and then how to convert any given complex number x plus iy form into trigonometric form or polar form. Thank you for watching this video, and in the next video we'll come with the next content. Till then, bye. Have a nice day. Thank you.